So they told me I need to use this so that I can be heard. So my name is Michelle Welker. I'm a senior data analyst at Mary Lou Fulton Teachers College. And my presentation is on using Alteryx to turn survey results into an AUDB database. So just to get a sense of who's here and what your background is, how many of you deal with survey results in some way? Okay, a lot of you. Awesome. How many of you have used Alteryx before? Okay, a few of you. How many of you went to the session right before lunch about Alteryx tips and tricks? Okay, a couple of you. Hopefully this won't be too repetitive. I don't think it will be. And then how many of you use AUDB in some way? Okay, all right, this is a good mix. So I think there will be something for everyone in the presentation today. All right, so to begin with, let's just talk a little bit about surveys. At Mary Lou Fulton, we do an end of program survey at the end of every spring and fall term for students completing their program. What are the reasons that we do so many surveys here at ASU or in higher ed in general? And you can go ahead. To get grant funding, that's true. Grants often require some sort of survey data. Yeah. Yep, regulatory requirements. That's absolutely right. What else? Any other reasons we use survey data? Go ahead. To improve. Okay. On what dimensions might we be interested in improving? Yeah, student satisfaction, student experience, student success. We do employee surveys as well too, right? So it could be employee satisfaction. All right, so those are all great answers. I had a couple others. Continuous improvement efforts, student experience we talked about, grants, accountability, accreditation, regulatory requirements for our diversity and inclusion efforts, and just in general, data-driven decision making, which we kind of encompasses all of it and which we're always involved in. So this is a little bit of what our survey looks like. It's pretty typical. We've got the Likert scale questions. We have other kinds of multiple choice and free text questions on our survey. We had been doing the survey for a number of years. We use Qualtrics, and over the years, we had all these survey results sitting out there that were kind of used a little bit by a few people, but we felt like we could make better use of them if we had them all together in one spot. So just as an outline of what I'm going to talk about today, I'm going to start with the background of where we were before we started this project and what our project objectives were. I'm going to talk about designing a relational database, and then go through some of our data wrangling steps with Alteryx and hopefully have some Alteryx tips you can use. And then talk about what's next and answer any questions you have. Or if you have any questions while I'm going through my presentation, please just speak up. Yeah. Sure. So Alteryx is a data tool that helps with kind of cleaning up and transforming data, putting it in the format that you want, among other things. And I'll give you some more examples of that. And then AUDB is our user databases that we have here at ASU. If you need to create a database, a special database just for your department, for example, you would do that through AUDB. Yeah, good questions. All right, so as we started off this project, these were the challenges we were facing. So each semester survey was a separate survey and separate results in Qualtrics. And it wasn't connected to the other surveys. And we could export it to Excel, but then again, they would just be separate files in Excel. Can you guys hear me okay? Am I too loud? Okay, all right, thanks. Lack of access. So those results, when they were sitting in Qualtrics, were only available to people who had a Qualtrics account and who had been given access to that specific survey, which we wouldn't necessarily want that to be widely accessible, but we still wanted them to be able to access the data. Another issue was change over time. As you know, surveys change over time. Each term, the questions could change or the order could change. Some questions could be added, others could be removed. And so it was tricky to be able to track over time how our results were improving. And then the last challenge was the format. We could export the results to Excel, but it was in an Excel file that was not in a very good format for data analysis or querying or anything like that. So the format was not a very useful format for us. So the solution that we came up with was to request an AUDB survey database. Like I mentioned, it's a user database. I've heard it's called Aurora user database or Analytics user database. And you can request it from the analytics team. Ours was called MLFTC survey team. And the reason we felt like this would help was we could have all of our results in one place, in one database for all of the terms. And in fact, we could include future term survey results and also results from other kinds of surveys, not just our end of program surveys. Access to AUDB is already controlled by analytics through your ASUID and through the regular protocols that they have for controlling access. So that was something we wouldn't have to worry about. We developed something called question sets, which I'll talk more about in just a minute, so that we could track our results over time, even though the survey questions might be changing over time. And because it's in a database with tables and rows and columns that we're familiar with, it was queryable through SQL or to do visualizations with Tableau. All right, so the first step in our project, which was the step that actually took the longest, was designing our relational database. And my biggest tip is go ahead and request a consultation with the enterprise technology folks, because they were so helpful to us. The way you can do that is if you go to the analytics page under support and select request consultation, and then just enter in your project. And in our case, we told them about our project. Bob Sukvong came out met with us, and we explained to him what we were doing. And then he connected us with Delaney Dickerson, who is a database expert. And she met with us, learned about our needs, what we wanted to do, and kind of gave us some things to consider and some really good advice about how we needed to design our database. So a relational database. The reason it's called a relational database is because it has multiple tables. So tables with rows and columns, and they're related by common fields or keys. So this is what we were designing. And there are some principles of good database design that I want to mention here. One is that you want one observation per row. So for a survey, an observation might be one answer to one question. So just one observation per row, and each row should have a unique observation. Another principle is you want one value per cell. So for example, one of our questions is, which grades did you do your student teaching in? We don't want a bunch of grades listed there. We want just one value in each cell. A table or a relational database needs to have unique keys. It's relational. In order to relate the tables to each other, you have to have the same keys in both tables, and they need to be unique, so you're not cross-joining data. And then the last thing that was important for us is expandability, by which I mean that we wanted to be able to continue to add survey results to our tables. And then we wanted it to be flexible enough that we could use it for different kinds of surveys too, not only our end of program surveys. All right, so here is an example of just a few columns from our results file. This is the results file that we would export from Alteryx into Excel. And there was something like in the neighborhood of 25 questions on the survey, depending on the term, but each question would have multiple parts to it. So our results file had something like 200 columns. It was huge. And you might hear people talk about wide data versus long data. So this is an example of wide data. If you scrolled all the way through it, you would see all of those 200 columns. It's really wide. And wide data is what we're often used to. It's sometimes called tabular data because it looks like a table or it looks like a spreadsheet. It's the way we typically do things in Excel. It's a good way to see a lot of data and make sense out of it. But it's not great for data storage or for querying. And so for that, you want long data. And this is an example of what that same data would look like in a long format. You'll see that each row is basically one question answer combination. So we've got the response number, or response ID is the first column, and then the question ID, then the question and the answer. And the first, whatever 200 rows would be just the questions and answers from the first response. So you can imagine how it gets really long, hence the name. All right, a couple other things I want to point out about our results file. One is, as you can see, each row is one response, or in other words, one survey submission. And in that row, it would have information about the student who submitted the survey, maybe how long they took, their location, what language they used, and then we'd also have all of the answers to all of the questions, and maybe some other kinds of data that we decided to pull in. This violates our principle of having just one observation per row, right? You can see each row in this file has lots and lots of observations. Our other principle was having only one value per cell. And you can see in our results file, some of the questions had strung together a bunch of values in one cell. And then the other odd thing about the results file is typically the top row in a table like this would be the header row. It would tell you what each of the columns were. But in this, we kind of had two header rows. The very top row had the question ID numbers, and then the second row had the questions. And then in the third row, it started the actual data, which again is good for seeing it, for looking at it, but not good for querying or data analysis. So as we were planning our database, and as you're planning how you want to have your database structured, a couple things that are helpful to think about are entities and attributes. What are the entities and the attributes in your data? And entities are like things in your data. So for example, our entities were the surveys, such as a fall 2022 end of program survey. Responses, like Miranda's submission to the survey. The students, like Miranda. The questions, such as what was your major, and the answers, like secondary education. Those are the things in our data set. And as you're planning those entities, those things typically become the tables in your database. Then you can look at the attributes of each one of those entities. Those are the properties or the characteristics of those entities. So the attributes of our surveys are survey name, the term, so on. The attributes of the respondents would be the respondent, the date, maybe how long it took. Attributes of a student would be first name, last name, ID number. Questions, we'd have question ID, question text, answer and type. These are the columns that you're going to have in each of your tables. So that's why it's useful to think of entities and attributes. Now, this isn't a hard and fast rule that you have to do it this way, but this is just kind of a way of conceptualizing it and planning out how you want to do it. And it's not always clear which would be an attribute or an entity. For example, student could be an entity. We could have a table of just all the students, but it could also be an attribute of the survey. One of the characteristics of the survey, or I'm sorry, of the response. One of the characteristics of the response could be the student who submitted the response. So there's a little flexibility there to make it work for you. So this database diagram was our first draft in how we structured our database. As you can see, we've got 5 tables for the 5 entities. But I'm not going to spend a lot of time on this because we decided it was too complicated and unnecessarily so. We wanted to simplify. So after a few more iterations, this was our final version of our, this is our final database diagram to describe the database that we ended up setting up. And the way that we made this a little simpler is we grouped the questions and answers together in one table here. And then we decided that student was more like an attribute, and we put the student information in the response table here. So I'm just going to kind of walk through it. If you're not familiar with database diagrams, I'll kind of walk through how this is used. Each of these rectangles is a table. We'll start here with the survey table, and then these items listed here are going to be the columns in your table. So we've got survey ID, and it says PK next to it because it's the primary key. It's the unique identifier for each survey in this table. And then we've got survey name, term, description. I added this field. I stole this idea from the term table in Redshift because the term in our database was the 4-digit term code, which for those of us that work in data, we're probably familiar with that. 2221 is spring 22, but our users aren't all familiar with that. They would mostly rather see a name like spring of 2022. So I added in these names that we could pull into Tableau or whatever visualizations. And this is the formula that I like the best, because if you have the semester name first, like spring 2022, and then you try and sort it, it'll sort alphabetically. Right. Yeah, it'll sort all the falls first, and then all the springs first, and then all the summers first. But if you put the year first, and then if you add an extra space before spring and summer, then when you sort those term names alphabetically, they will also sort chronologically. So that's just a little tip that I use all the time. And that's why I added it to the table, because I use it so often. All right. So that's the survey table. And then if you look at this, this line here that connects the survey table up to the response table, you see these marks on the two ends here, and this indicates that it's a one-to-many relationship, which means that each one survey can have many responses. If you think about a survey, that makes sense, right? One survey has many responses. And we've got the survey ID here that links to the survey ID in the survey table. That's how these tables are related. And in the response table, it has its own primary key, which is a response ID. I'm not going to go through all these fields because they're mostly boring, but we do have EMPL ID. We have a few student fields. We felt like with EMPL ID or student ID and term, we could pull any other student information that we would need. You know, we knew we'd probably want to pull their majors, maybe some demographics about the students, but with that unique identifier for the student and knowing what term we were talking about, we could pull that from other tables. We didn't need to store that in our tables. All right, again, from the response table, we have a one-to-many relationship to the question answer table, meaning for each one response, there will be many questions and answers, right, that the student went through and answered. It again has a unique primary key. QA ID is the primary key. And then the response ID that relates back to the response table. And then the only other fields we had were QID on survey, question set, which I'll talk about in a minute, question text, and answer. So this again is the long table that I gave you the little visual about just a minute ago. It's the longest, the table with the most rows in our whole database. Oh, and the reason that's useful is when you create your table, when you first design your table, you decide how many columns it's going to have, and then you can just keep adding rows forever. But it's more difficult to add columns later. So if we had created the table with one column for each question, and then next year they added 3 more questions to the survey, we would have to redo the structure of the whole table. This way, by just having each row be just one question answer combination, not a specific question, but any question answer combination, we could just keep adding rows onto the bottom forever. So it makes it expandable. Yeah. Okay, the question is, why didn't we include the survey ID in the question answer table? And the reason is we don't need to, because we can reach it through the response table. I mean, we could have put it in there, but it was unnecessary. but that's a good question. So yeah, we'd have to link through the response ID and then to get to the survey information. Good question. All right, one more thing, one more really good tool to use as you're planning your database is a data dictionary. It's good to kind of get your thoughts down on paper, think through all the things that you'll need to define in your database. And then it's also excellent for documentation. So you create this database, you populate it, you move on to another job, someone else comes in and looks at the data, and you need a data dictionary so they'll know what each of those fields are. So this is a data dictionary for the question answer table. And we've got the primary key, the field name, and then we've got the data type. In this field, they were all strings, but it could be date, it could be numeric, it could be a Boolean, yes, no type question. We've got an example of what that type of data looks like, and then any other notes that might explain how we developed it or any nuance people might need to know. So I recommend you always do a data dictionary with any type of tables that you create. Okay, next step in the process, now that we had our database planned out and designed, is data wrangling. And these are the data wrangling steps. I knew my presentation would be right after lunch and everyone would be kind of drowsy, so I wanted to come up with something interesting to look at. I asked Starry AI to draw a picture of an ASU data wrangler, and this is what they came up with. And I said to include a lasso. I don't know if AI really knows how a lasso works. That's a very odd lasso, but it's very dramatic looking. So I think this can make us all feel really cool as we're doing our data wrangling. Cool and tough. Starry AI. Starry AI. So these are the typical data wrangling steps that you'll go through in any sort of project like this. The first one is discovery, which I pretty much already went through. It's understanding the data that you're starting with and what you need to do to make it useful. All right, for the next data wrangling steps, all of these steps, we used Alteryx. Now, if you're a whiz with Excel, you can probably do a lot of your data wrangling in Excel itself. But there are some advantages to using something like Alteryx. It's more efficient because it's, you can tell Alteryx to apply whatever transformation to every element in this column or every row, whereas if you were doing it by hand, you'd have to go to each one of those cells or it would just take longer. It's less error prone because, again, it's done by the computer instead of a person. We're all subject to error. It's less risky because you're not actually modifying the results file itself. Alteryx creates kind of like copies of the file at each step along the way. So if you make a mistake and delete a row you really needed, it's easy to go back to that step, undo it, and then just keep going through your process. And then this, to me, is the most important reason to use something like Alteryx. It makes your data wrangling steps replicable. So, and there are two things that I'm thinking of when I say replicable. One is, once I created the workflow for the first term of survey results, then when we have our next term come along, I can reuse the same workflow. I can hit run, and within just seconds, it'll do all those same data transformations on the data. Or maybe I need to tweak it a little because they asked some different questions. But again, it's much quicker than having to do it by hand. The other way it's replicable is if you're doing the kind of project where you need to document the steps that you took, particularly if it's something related to research, where someone else might need to replicate your results at some point in the future. Using Alteryx, it automatically documents every step along the way, and so you can just share your workflow with someone and they can see exactly what you did and do it themselves. So it's a really helpful tool. So this is what my Alteryx workflow looked like. I know you can't read very much of it because it's so tiny, but I just wanted to give you an overview. Each of these little icons that you see is what's called a tool in Alteryx. And you put them together in a workflow like this. And this whole area that you see here is called the palette. So it's kind of where you can see your workflow visualized. So I mentioned how Alteryx is a great tool for documenting your process and being able to replicate it later. And I want to share real quick a couple of tips that help with that documentation process that's so important. First of all, you see these maroon and gold kind of boxes. Those are created with a tool called Comment in Alteryx. And I use this, so each of these maroon bars is a section that describes which section the workflow is. So for example, this section is to create the survey table. This section is to create the response table. And then this bottom section is to create the question answer table. So for the next person that comes along, they can kind of see really easily what this workflow is trying to do. In the gold boxes, those are just the kind of instructions to myself about what I need to do each semester in order to use this with a new semester's worth of results. Change some names, make sure you put this is for fall 2022 instead of spring 2022, and so on. Another great tool to use is within each tool, you see some of them have a little box underneath. Within each tool, there's an annotate function. So if you click on annotate, you can add, again, your own notes about that specific tool. And then the last thing that I like to use a lot is these big rectangles that have tools inside them. These are called containers. And I like to use the containers to kind of visually organize my workflow again, so someone else looking at it can kind of see the different sections of the workflow. For example, this container here is the answer columns. This container down here is the question columns, and then I bring them together here at the end. You can add a description in each container. And then the other great thing about them, you'll notice that at the end of each workflow, I have the last tool, which is an output tool, in a container that's shaded in. You can enable or disable a container. So when I'm doing a workflow, I always put the output tool in a container and then disable it. So then I can run the workflow as many times as I need to without actually populating the database or creating the file or whatever my output is. Then when I know everything looks okay, I'll enable the container, I'll run the workflow, populate the database, and then I immediately disable it again before I save it, so that there's no chance of someone else coming in, opening the workflow and running it and accidentally doing something to my database. So I use containers in that way pretty much in all of my workflows. All right, so now I'm going to get into some of the tools that I use for structuring. We're getting into the next step of data wrangling, which is structuring. A filter tool is just what it says it is. It's a way of filtering the data. This is kind of a zoomed in look at part of my workflow. So I use the filter tool right here, and each tool has input anchors, one or more, and output anchors. So on a filter tool, the output anchors are true and false based on whether the rows in the data meet the criteria that you put in the filter tool. So it's a tool that I use for lots of different things. Like I said, I used it to separate the questions and the answers and then apply different data transformations to each, and then in order to bring them together at the end. I also used, you remember that weird second header row that had the questions in it? When I was creating the response table, I just filtered that row out because we didn't need it at all in the response table. All right, transpose and crosstab tools. We talked about making our wide data tall. And if you look at the little pictures on these tools, you can see that's exactly what they're doing. The transpose tool will make your wide data long, and the crosstab tool will make your long data wide. So depending on what you're trying to do, you can use one of those. And again, what I used that in the workflow after kind of cleaning up the data, the question and the answer data separately, in both cases, I took those columns and made them rows instead with this transpose tool. Okay, more structuring. We talked about in our tables, we needed to have these unique ID numbers. Sometimes you'll have a unique ID number in the data itself. So we had a unique response ID number for each response, but we needed to create a unique survey ID number and a unique ID number for each row in the question answer table. So the record ID tool will generate a unique ID number. You can indicate how many digits you want it to be, and it'll just be an automatic, sequential unique ID number. We wanted to add a little more information to our question answer ID number. And this goes to the question you asked about why didn't we bring our survey ID into the question answer table? This is the way that we brought that information into the question answer table. As we were generating our unique ID number for each row in the question answer table, we added this survey ID number, which includes an abbreviation for the survey name and the term, just so that if someone was looking at only the question answer table, they would have an idea of which survey each of those questions and answers relates to. Does that kind of make sense? It wasn't necessary. It was just another way of adding a little more useful information to the table. All right, the formula tool. This was kind of the trickiest part of our workflow. And you remember when we looked at the results file, we had the one question where it asked, what grades did your student teach? And it had a bunch of grades strung together. And if you have a field like that, you can imagine how that makes it really hard to filter or sort or anything when you can have a random number of numbers strung together, separated by commas in that field. So what we wanted to do was to create a separate column for each value in that field. So this little table here is just a kind of a sample to illustrate what we were trying to do. Obviously, it could go from pre-K all the way up to grade 12, but this is just kind of an illustration. So Q4 here, our first column, represents the original column in the data where they had the grades strung together. And then these other columns were the columns we wanted to create so that there would be a separate column for each grade. So if I wanted to pull only the teachers who taught grade 1, I could look at just this one column. So column 4.1 would be the pre-K column, 4.2 would be kindergarten, and so on and so forth. And so what we wanted to do was have the formula look at the original value and then populate the columns accordingly. Does that kind of make sense? Okay. So it didn't quite work out the way that we thought it would based on the formula. And on this next screen, I'm going to show you what happened and see if anyone can figure out why. So these are the formulas that we use. This little screenshot is actually from Alteryx. And what it's saying is create a new column called 4.1. And if the original column, Q4, contains the string pre-K, then put pre-K in our new column 4.1. And then we did this for each grade. If the original column contains K, create a new column called 4.2 and populate it with a K. So when we ran our data through these formulas, and again, we did it all the way up to grade 12, we ended up with some data that wasn't exactly correct. Can anyone see the problem? Oh, very good, Twyla. Okay. I'll give you a second to, I see some heads nodding. So you can see the problem here in the data. It put a K in the K column, even though kindergarten was not a value in the original column. And why did it do that? Right, right, because we were telling it if the original column includes a K, populate the kindergarten column with a K. And we couldn't say if it equals a K because the K could be anywhere in the string. It could be by itself, it could be at the beginning, it could be at the end, it could be before or after a column. So there wasn't a really easy way to say only pull the K if it's by itself. So I'll tell you, in Alteryx, there are a dozen different ways to do anything. So probably if someone else encountered this problem, they might come up with a different solution. But this is the solution that we came up with, which is we used a find and replace tool, which will find a particular string and replace it with a different string. So we said, anytime in the data you see a pre-K, replace it with pre. And that resolved the ambiguity because it didn't have a K in it. And then we rewrote our formula. So it said, if you see a pre in the original data, then populate the pre-K column. And I'm using this as an illustration, but we found it throughout our data because you can imagine the same problem came up with grade 1 versus grades 10, 11, and 12, because they include a 1. It also came up in our subject matter because we had an early childhood subject, a special education subject, and an early childhood special education subject. So you can see that same ambiguity there, and we used the same kind of tricks to get around it for each of those examples. And I'll show you where that is in the workflow, right up here. We've got these two find and replace tools. One was for the grade level, and then one was for the subject matter. And then this input tool would have the values that we wanted to replace the ambiguous values. All right, hopefully that makes sense. Okay, we're moving on to the next data wrangling step, which is cleaning the data. And Alteryx has a great tool called, logically enough, the data cleansing tool. And I won't go a lot into it, except just to say that you can designate that it applies this to specific fields or all fields, any one or all of these data cleaning techniques. For example, I got a data set the other day that had like 15 blank columns at the end. That was just the way they gave me the data. I was able to run it through Alteryx real quick and just remove those blank columns. Obviously, you want to be careful and make sure you're not removing something that should be there, but this is a real quick and easy way, especially when you're talking about things like white space or punctuation. If you just want to strip it all out, this is a quick and easy way to do that. All right, we're halfway through our data wrangling, and we have another super cool ASU data wrangler with her data lasso. 3 steps left to data wrangling. And this next one is another one that I mentioned at the beginning, being able to change or track question change over time. So to illustrate why this is important, I want to show you an example of a question from our survey. In fall 2018, you can see the question up there. Prior to attending a teacher prep program at Mary Lou Fulton, had you ever worked as a classroom, blah, 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 blah. That was the original question. And then this QID, Q9 was the QID internal to Alteryx, not what the student would see. So 2 years later, in fall 2020, they felt like they needed to expand it and say at Mary Lou Fulton or ASU, because some of our teacher prep programs are not within Mary Lou Fulton. And then a year later, they made a minor change, which is they stopped including the question number in the question. And then a year after that, they completely redid the survey, put all the questions in different orders, has a different internal question ID number, and they kind of broadened the last, instead of classroom assistant or substitute teacher, they just said an educator. So if I wanted to query the data and say, what were the responses on Q9 over time, it wouldn't find, I mean, we all agree this is basically the same question, right? They're getting at the same point, but because both the ID number and the question text changed over time, it was hard to pull all of those results together. So what we did is we created an Excel spreadsheet that we called the question crosswalk. We went through each survey and indicated on which surveys these questions were asked, and then we created a question set to group all of those questions together. And it's just a little string of words that would kind of, tell you what kind of questions they were. The prefix indicates the section of the survey in which the question was asked. So this was the background section of the survey, and then just a couple words to indicate what the question was about. And then, so this is just showing that all of those questions, even though they were different, would have the same question set applied. We used an input data tool to pull in that Excel file into our Alteryx workflow, and then a join tool to join it with the rest of the data. So right here is our input tool that pulls in the question set crosswalk. Here's the join tool that joined it with the rest of the data in the workflow. And then because the join tool has 3 outputs, left, inner, and right, depending on what kind of join you want to do. In this case, we wanted all of that data to be unioned together. So we also used a union tool, which is what this is right here. And this is a way of enriching the data, adding a new field that wasn't in the original data, but that would allow us to do the kind of data analysis that we wanted to do. All right, validating. The browse tool in Alteryx is one I use all the time. As you've seen from these examples I've given you, even though we were using Alteryx, it can still produce results that are not exactly what you want. So you need to validate it multiple times throughout the process. You can just drop a browse tool at pretty much any point in your workflow, and I use them a lot. And if you click on the browse tool, it will show you the results. If you were to output the workflow at that point, wherever the browse tool, it'll show you what your results would look like. So down here at the bottom, we've got all these rows and columns. And then it has this little bar under each column header, which if you hover over it, it'll give you some brief statistical information about the results or the observations in that row. And then another thing that's in the browse tool is if you go into the configuration, it'll give you additional statistical information that will help you validate the data, make sure it's looking like what you want it to. In this case, it's not odd that there are so many empty cells because the question was something like, is there anything else you think we should know? So lots of students just didn't answer that question. All right. The final step in our data wrangling process is publishing. Alteryx has an output tool. You can output to an Excel file, various other kinds of files, or to the AUDB database. I already mentioned using a container to deactivate the tool until you're actually ready to populate the database. Another tip I'll give, especially if you're using with AUDB, is always output to a test table first. And you can just create a test table by, I just put test in front of the table name, particularly if you're updating a table that already exists. You run it to the test table first, make sure it's doing what you think it is, not overriding rows that you don't want it to. And then you can go into dbeaver, run some queries on it, make sure it looks good, and then you can change it to output to the real production table. There is an awesome video on the analytics training site. If you look up Alteryx, the video is called Ins and Outs of User Databases, and it goes through exactly the steps to output an Alteryx workflow to an AUDB database. There are specific steps you need to take in the configuration for the output tool, and that video has it all. It's great. Okay, what next? So what's next for us is we'll continue adding survey results to our databases and hopefully add other kinds of surveys that we have results for. We can expand access, through the analytics site, just like access to any other table. We can analyze the results across time. And now that they're in a database, we can query them with SQL and we can create dashboards in Tableau. So speaking of which, let's see if I can access this dashboard. So this is a dashboard that we created from this database that we created in this project. It's just for one particular section, but you can see we've got the results. This is Likert scale results from not very confident to very confident. How confident does the student feel in their ability to implement these various teaching practices? So again, you can see it across time. We can see how many students responded in each level of confidence. We can see the average overall average Likert score. And then because it was in AUDB and we were able to pull in additional student information like major and demographic information, the programs can now go in, and if the elementary ed program wants to see how only their students did, they can hopefully go in. Maybe it got disconnected while I was doing my presentation. It did. Oh, wait, reconnect. There we go. Give it a minute. Okay. And then we can select just elementary ed. And it thinks there it is. And they can view only their results. So each program can look at how just their students responded on the survey. We've also added some other visualizations. For example, this one compares results for students who are or are not a minority, and for students by gender. So comparing the experience of female and male students. So all of this is available now because we were able to load all of those results into our database. See if I can get back to my presentation here. There we go. And that's it. Any questions? Yeah. Mm-hmm. Mm-hmm.
But there are various the questions really go back. Has there been any in-depth analysis about why those responses are changing?
So excuse me. So this is as far as we've gotten. We just have started creating the dashboards and we haven't rolled them out yet. So we think there will be that kind of impact, but we're just not that far along in the process. But that's what we want it for, right? So that data-driven decision-making is what we want this for. Any other questions? The question was, has there been a comparison between how they respond on the survey and how they're doing in school? Was that kind of what you asked? Right. So this is an end of program survey. So by the time they complete it, they're basically done in school. But I think that would be an interesting question to ask. And I don't know if it has been. Is their satisfaction related at all to how well they did in school? I don't know. That's a great question. I don't know if anyone's gone back and tried to make that comparison. I know. Yeah, well, and that's what, this is what we can do. We're just at the beginning, but this is what we can do because we have a database. None of this would have been available to us when we just had, 20 different Excel spreadsheets sitting out there. So. Right. Yeah, so the comment was just that now we can do a lot more than what we could do in Excel alone. So yeah, thanks. Go ahead. Alteryx. That is a really good question, and I don't know the answer. I've never done that in Alteryx. I don't know. Good question. I'll have to look it up after this. Yeah. You mean when did they start giving the survey? Oh, it's in Qualtrics. They use Qualtrics to administer the survey. Yeah. Correct. Yeah. Yeah, if you go into Alteryx after the survey is complete, you can export the results to Excel. And that was our input to the Alteryx workflow. Exactly. Uh-huh.
Clean up the data, and to place the data in the data repository, and then give a base reporting. But it doesn't seem, this is not the tool that you'd be using to create the final analytical reports, correct?
Right. Alteryx was used to clean up the data, to populate the database, put it into AUDB. This visualization that's on the screen now was done with Tableau with a different tool. Good question. Yeah. Yep. And we used a query. We used a custom SQL query in Tableau to query the data from the AUDB database and bring it into the visualization. And if you have any other questions later, reach out to me. And then I also have some other links that might be useful for Alteryx and AUDB. And that's it. Thanks. Great questions.